Hi, Walter. This is Michael at Applied CAX. Excuse me. I wanted to go over an example here of how to process a toolpath that you're experimenting with, how to process it more quickly initially, and then come back and reprocess it at a higher tolerance. So, sorry. The example I'm using is out of the default install directory. So Siemens, in my case, 2206, mock, resource, library, machine, installed machines, sim08, cam setup, and then I opened this toolpath here. It has a variable axis guided curve toolpath that I've reduced the step over quite a bit. So backing up a little bit, I don't know how much you use the methods group. So I'm going to give you a little bit of an overview of the methods group. Basically, they're like folders where you can set your stock and your in tall, out tall. They also have kind of a library. In this case, this is a differentiator between the processes. So a different library reference between the processes for roughing, semi, and finish milling. And this allows the speeds and feeds library to change the speed and feed for a cutter. This is one of the things it would look at. So that's one of the purposes, but main purpose is setting part stock and in tall, out tall. Then you can customize colors. And the reason it's broken up into, you can define how much you break it up, but the advantage is for all these toolpaths that are under rough, so under tolerance, they're inheriting the tolerance from this rough group. So the advantage is if you want to change your process more globally, you can do that at this level and say okay, and everything underneath except for this one, because here's a good example. It's locally defined, so the lock is open, but if I say inherited, now it's inheriting from that upper level. And then these other ones that updated are obviously inheriting. So this could be handy, for controlling it globally, or if you're taking a set of processes from one part to another and you want to repurpose them by adjusting how much stock or changing the tolerance because you're cutting a different kind of part, but you like the toolpath shape, you like the toolpath lead in and lead out. There's other things you like about the toolpath, you want to reuse it. You could drag it into that group into this folder and they'd all update given those stock and tolerance values. Another use case might be you might have another group. So what I'll often do, so it kind of stands out, is I might put like a dash, I don't know, ST for stock and 20 for tall, whatever. You can come up with your own naming, but you can kind of see without going down into the groups, what they're set to. You can also see, so maybe not in this case. Oh yeah, you can. There's stock. I don't see tolerance, but that might be something that we can add through columns. In this case, it's not. So yeah, so I was just seeing if it is. I don't see tolerance, but at least you can see the stock amount. So That, at least you can see that in this view, and maybe in a different view you can see all the views have kind of different options of what you can see, but it does not look like tolerance is one of them. So another use case might be it's all about reusing toolpaths across parts. So, or maybe you want to take a group of toolpaths that are in roughing, and you want to semi-finish, but in one area of the part, you're going to leave less because you're coming back to finish with really small cutters. And so in that case, you might have a semi-finish group that's set up for semi-finish previous to smaller cutters, and then another semi-finish group that's for semi-finishing previous to some larger cutters where you can leave a larger amount of stock. So that's kind of the overview. But the other thing it's handy for is your method group can also inherit its tolerance. So let's say I have, it's kind of hard to see because it's inside of another group. Here, I'll drag it. Not necessarily up there, but so now it's not in a group. I'm going to collapse some things so it's a little easier to look at. So let's say I have a toolpath under under here, and it's just called testing. I'm putting a bunch of toolpaths under here that I'm experimenting with. And I have these two other, so one option is as I'm experimenting, I could come in and adjust these manually, and that would adjust everything under it. And that is fine. That's a good process. But another thing you can do is set up two folders that are like going to be the parent to that folder, and they're going to set it. So let's say one of them, I'm making this extreme because this is metric in this case. And then this is process, let's go, I don't know, even higher to try to see a difference in time. So now if I take this and I drag it under process fast, and I'm going to go all the way down to the operation itself. Oh, this one's not set to inherit. So now we're under the process. Oh, did I do that wrong? Oh, so you do have to check. You gotta do this once, but once you do it, it's all good. So they were, this can be locally defined because there's nothing above it, but you just have to make sure everything under it is set to inherit. And so the lock is locked, and so now it's inheriting. So in this case, it's 500 micron. And so if I process this, oh, let's look at what the step over is. Okay, so we'll do, it was working at this. So there is a limit to what you can do, and of course you probably wouldn't set your step over. Let's make this rather than scallop, so I know. Let's make it 0.1. And then we'll make this 0.1. So that's the loosest we can go. And so you could always, so 0.09. There we go. I just wanted to show you how to make mistakes. So there's, fast. And then we take this to here. And now if we look at it, we have a tolerance of less than a micron. And you can see, I'm glad it at least shows a difference. Now it's really thinking. So there's, small toolpath, but it's definitely thinking harder when it comes to the processing speed. if it even processes. I'm going to make you wait. Nice. It's oh, it was at 100%. I wanted to see if it was using multi-cores. Yeah, it is. It's not, it's not hitting 100, but it's doing 50%. So it's hitting a couple of my cores harder than the rest. But at least it's says it's using 6. Wow, I didn't realize I had so many cores. And one thing I could do to, while we're talking about process speed, also is, you can reduce your cores by going into, because normally a computer is set up in the BIOS to split the cores into 2 virtual cores from 1 physical core, and so it doubles your cores, but they're kind of virtual. So in cases where you might not be utilizing multi-core processing, um, hyperthreading isn't helpful if you want just speed. So, I would suggest turning that off. All right, well, you can see it's a big difference. So that's kind of an example of how to drag your operations from one mill method group or folder to another, and inherit, this looser tolerance and higher tolerance, and really increase or decrease your processing speed. So in the end, of course, you want the tolerance that you need, but while you're investigating, you'll still see material removal if you loosen that tolerance up. So I'll send this video your way. Thanks a lot.